For question number 13, again, just like question number 12, you don't expect this type of, you don't expect you are going to get this type of question in your test. That is because it doesn't ask you to calculate anything. It is asking you to manipulate equations or modifying equations. This is what is going to be involved. So you don't expect you will get this type of question. But by the way, I will show you how it is solved. First of all, let's go through the questions. For a given allowable stress, the ratio torque over W is the weight per unit length of a hollow shaft, which has an inner radius and an outer radius of C sub 2. So you are asked to determine that ratio. Then there is a part B, and you have to take this T over W not as the ratio for a solid shaft of the same radius C naught. Express this T over W of the hollow shaft in terms of T over W of the solid shaft and the ratio of the inner and outer radius of the hollow shaft. So the question itself is very complicated, but by the way, let's carry on. There are two parameters here. First of all, T is the torque. That is already quite obvious to everyone, and this is something less obvious to most people. Lowercase w. That is the weight per unit length mentioned in the question. And what does it mean by weight per unit length? It is the total weight over the total length, uppercase W divided by L. So the total weight can be expressed as gamma. L, in this case, gamma is specific weight. Okay, and the weight per unit length equation can be further simplified as gamma times cross-sectional area A, and it is equal to gamma times pi outer radius square minus inner radius square. That is the formula for cross-sectional area of a hollow shaft. Then let's come to the torsional stress equation, T times C over polar second moment of area. And in this case, this is referring to the outer radius, so I put C sub 2, and it can be rearranged so that we have the torque at the left hand side and tau and J at the right hand side divided by C sub 2. And let's substitute the equation for polar second moment of area for hollow shaft into the equations. So the torque is equal to pi over 2 C power 4 minus C power 4. This is C sub 2 and this is C sub 1, and everything divided by C sub 2 times tau. And these equations can also be written in this way: C power 2 plus C sub 1 power 2, then C sub 2 power 2 minus C sub 1 power 2 times tau divided by C sub 2. Okay. Now it is the time to take the ratio of T torque divided by weight per unit length, and this is the case for hollow shaft. So if I'm going to do this, basically I'm going to take these equations divided by these equations. So I will write it here. Two, one, 2, 1. So I will cancel out identical term. Pi cancel out with pi. This one minus the cancel out with this one. Then I end up to have tau divided by 2 gamma. Then I have c sub 2 power of 2, c sub 2. Then okay, before c sub 2 gamma c sub 2 square plus c sub 1 square. Okay, this can also be written in this form. C sub 2 square over c sub 2. So I will have 1 plus c sub 1 over c sub 2 square over here. That is the solution for part A. To express torque over weight per unit length in terms of the ratio of the radius, inner and outer radius. Okay, let's move on to part B. In part B, you have to create one more expressions for the case of solid shaft. And for this solid shaft, you only have one radius because you don't have inner and outer radius. And after that, you need to express it as a ratio of solids for hollow to solid shaft in terms of the ratio of the inner and outer radius of the hollow shaft. It sounds complicated, but let's see how it works. Okay, so this is the expression we are going to make use of. It represents the ratio of torque to weight per unit length for the hollow shaft. We are going to create another one for solid shaft. And for solid shaft, you don't have inner radius, c sub 1. So if you apply this into these expressions, and we are doing it for solid shaft, so it ends out as tau c sub 2 divided by 2 gamma. So if you apply c sub 1 equal to 0, the whole item inside the brackets is equal to 1. So it's simplified to this. Now, it is the time to take the ratio. T divided by W for hollow, ratio of T over W for solids. Let's take the ratio. Okay, you are going to have something like this. First of all, I'm going to reproduce the whole item here, the whole expression here. So okay, that is the ratio. So let's cancel out identical item. Tau and tau, c sub 2 and c sub 2, 2 gamma and 2 gamma. So you only have this left. So lastly, let's answer to the questions. That is to express the ratio of torque to weight per unit length of the hollow cross section to this solid, and it is equal to okay, this is the final answer for this question number 13. Again, I want to emphasize that you don't expect you are going to get this type of question in your test. That is because it doesn't ask you to calculate anything. It asks you to manipulate equations, and it involves very abstract mathematical operations. Okay, that's question number